Hello, and welcome to the Current Science and Technology podcast from the Museum of Science in Boston. I'm your host, Susan Heilman, and every week we bring you interviews with guest researchers and our museum staff covering science and technology in depth. Today we'll learn about a new flame retardant for clothing. Cotton is the most popular fabric in the world, but it is very flammable. Scientists have been trying to develop non-toxic flame retardants, and the museum's Corinne Tate is here to tell us about a new technology that may be used. Hi, Corinne.
Hi, Susan.
So, is there anything on things like cotton clothing right now that act as a flame retardant?
Yes, we add chemicals to a whole bunch of different materials to prevent them from catching fire or to make them burn slower. And it's not just on fabrics. We use it on electronics, on a bunch of different types of furniture, and of course on clothing.
So you say chemicals, a lot of times people think of, right, something that's toxic. So what are these things made out of?
Well, actually, a lot of the flame retardants that are used right now are toxic. In decades past, they used materials like PCBs, and currently a common flame retardant is called a PBDE. It stands for a polybrominated diphenyl ether.
And is that used on clothing or just on other things that's around us?
On clothing as well. And these are a big concern, these halogenated and brominated fire retardants. The concern is that they're very persistent in our environment, and that means they don't degrade or break down. These chemicals tend to stick around, and they build up in human and animal tissue, they build up in our food chain, and they build up in our environment. And people are concerned about their long-term effects, and these types of chemicals have been found to possibly lead to learning and memory deficits, even birth defects and thyroid problems. So there's a lot of concern over these toxic fire retardants. And as a result, a lot of them have been banned in a number of states.
It sounds like these chemicals that are being used really aren't the greatest type to be used on people's clothing. They're very close to people. That reminds me of asbestos. That was used as a flame retardant material in buildings, and even though we're not ingesting it or wearing it, it's still something that's been banned.
I mean, these flame retardants are kind of a tricky issue because they're very important. They have a lot of value for us in preventing materials from catching fire and slowing burning, and particularly with clothing fires, giving people that extra time to either remove that piece of clothing or put out the flames really does save lives and prevent some disfiguring injuries. So flame retardants are important, and we still want to use them. A better option than some of these toxic ones, though, is trying to find a water-soluble, less toxic flame retardant that can still be used on clothing so we get the benefit, but we don't have to be concerned about some of the toxic effects.
Right, if it's water soluble, then we don't have to worry about as much sticking around in our body or sticking around in all aspects of the environment.
That's right, it would disperse rather than build up.
So what is this latest group looking at in the area of water soluble flame retardants?
Well, some material scientists at Texas A&M University, Jamie Grunland and Yu-Chin Lee, have been working on a new technology that uses something called intumescence. And what intumescence is it's actually a common technology used in building materials to fireproof them. There is a type of fire paint that we use on steel beams, and at the first lick of flames, what it does is it bubbles up and expands almost like beer foam. And what that coating does once it bubbles up is it protects and shields the material below from the flames and from the heat. The problem is this kind of material doesn't really lend itself to fabric. It's a very thick coating. So this team thought that if they could make super thin layers of material that also intumesce or have this foaming chemical reaction, it could be applied to fabrics.
I never realized that when you see paint bubbling up when it gets hot on buildings. I thought that was just what the paint did. I didn't realize that that was purposefully done to act as a flame retardant. I thought it was just the paint melting. I didn't realize it offered a protective layer. But you're right in that that's not exactly what we want to have on our clothes.
So the way they get around it is they make super thin layers, nanoscale layers of a new polymer that will intumesce, or it expands and bubbles up and protects the fabric. And by making these nanoscale layers of this polymer, what it's able to do is it's really able to seep into the fibers and really penetrate every individual fiber of the material and still stay flexible and kind of maintain the quality of the fabric that we want.
So it wouldn't be a rigid coating on the outside, but could actually, I guess, intercalate in all the little fibers. But would that still make it kind of stiff and uncomfortable?
Well, there's two sides to this. On the one hand, the fact that it's so thin and it can penetrate every fiber, it works differently from the traditional flame retardants that we have. Those chemicals, because they form much thicker coatings, the traditional flame retardants, when we apply them to fabric, they just kind of settle on large bundles of fibers and act a little bit like an armor to slow the spread of the flame. Because this one penetrates at a much deeper level, it actually works better and it can prevent the fabric from even igniting in the first place. The flip side of that, though, is even though it is flexible and does maintain some of the quality of the fabric, some of their research is going to be in really fine-tuning the recipe of these polymers to optimize the look and feel of the fabric that we want to maintain.
So before we get into optimizing the recipe, what exactly is the current recipe now for these nanofibers? You mentioned polymers. What exactly are they using?
Well, they use alternating layers of two specific polymers, polysodium phosphate and a polyallylamine. And the benefit of these is that they're water-soluble polymers, so they are less toxic. And what they do is they take the fabric and they do kind of alternating dips in each one of these chemicals to form these alternating layers that when it's exposed to flame and heat, it expands slightly and really prevents the cotton from igniting by choking off the oxygen supply to the flammable material below.
So how would they be able to optimize that to not be as stiff? I almost imagine coating a candle wick in wax. You just keep coating it, it's going to get thicker. And you're right, it's still beneficial, but you mentioned they're trying to optimize it. What are they doing with that?
Well, the fact that these are nanoscale layers, really thousands of times thinner than single human hairs, the coatings are so thin that they do remain flexible. They are kind of tweaking exactly which polymer they use to just maximize the flexibility and softness of the cotton.
So these nanomaterials are water soluble, which is great for not sticking around in our bodies, not being as toxic, not sticking around in the environment as much. But when you're talking about clothing, normally people like to wash their clothing in usually water. So how can they get around the fact that it's water soluble, but it's going to need to be washed? You have to reapply every time you want to wear it.
That's a great point, and that's something that they need to address before this is used widely. That you're right, with repeated laundering, this water-soluble coating would eventually disappear. So that's another area of research as they try to develop this coating further. It needs to be persistent and even permanent, but they do have some ideas about how to make this nano-intumescent coating eventually permanent on fabrics.
So how did they perform some of these tests? They obviously didn't, have children put on pajamas that were coated with this and then, hold a flame up to it. But what type of testing was done that the scientists feel comfortable that it is an accurate flame retardant?
Well, what they do when they test materials is they'll apply a flame for 10 seconds to see if it'll ignite. And with regular untreated cotton, of course, as soon as you apply the flame, it catches fire and burns. With this flame retardant, when they did apply the flame for 10 seconds, it didn't catch fire at all. There was just some charring where the flame was initially applied. Now, of course, that's a pretty limited test. One thing we'd need to be concerned about is, how is it going to stand up in a major fire where flame is applied for obviously much longer than 10 seconds? How's it going to do in an inferno, for example? So obviously, more testing needs to be done to see just how it would stand up in kind of a real-world fire scenario.
Well, you mentioned several different issues that the scientists are going to have to address before this can really become, widely used or commercialized. But overall, it sounds like a really good idea to be using these nanomaterials in order to create a more useful flame retardant coating for things like clothes.
Yeah, it's a very promising technology that has the added benefit of being much less toxic and more friendly for us and our environment. I hope we'll see it develop.
I'm sure they'll be continuing on with their research and solving many of these issues. So thank you very much for telling us about this new flame retardant method.
Thanks, Susan.
That's That's it for this week's show, but be sure to come back next time for more of the latest in science and technology. This podcast is a production of Current Science and Technology at the Museum of Science in Boston, part of the Boston community for over 175 years. For more information, visit our website at www.mos.org/CST or email us at podcast@mos.org. Thanks for listening.